Good morning, good afternoon, good evening, everyone. Thank you for joining us today. Welcome to this webinar, which is part of the ongoing series hosted by ISO Technical Committee 347, Data-Driven Agri-Food Systems, as part of our commitment to transparency, engagement, and inclusive participation in the standards development process. ISO TC 347 is a new and ambitious committee working to develop international standards that enable trustworthy, inclusive, and effective use of data across agri-food systems. My name is Andres Ferreira. I'm the chair of TC 347, and I'll be your moderator for today's session. Webinar series is designed to explore key technical areas where standardization can support innovation, sustainability, and interoperability in agri-food systems. Today's topic is making sustainability actionable, managing hidden impacts at scale with standards. It relates to the complexities involved in describing sustainability in complex parts of the agri-food domain and in ways that include important environmental and social effects that often go unobserved. This is a critical area where shared standards can help connect diverse actors from farmers and researchers to technology providers and policymakers. Yet our understanding of the nature and scope of those potential standards and the forces driving them is still incomplete and evolving. Hence the need for discussions like the one we'll have here today. Today, we'll aim to describe the technical and strategic rationale for representing social and environmental externalities within digital agri-food standards. We'll discuss how such representations can be made compatible with existing ISO TC 347 entity and event models. And we'll show you how you can actively participate in shaping upcoming international standards. We're very fortunate to be joined today by Juan Gutierrez and Veronica Menendez, who will lead us through the discussion. Juan is a chief technology officer and co-founder at Agrolinera. He holds an MBA by the Wharton School at the University of Pennsylvania and has ample experience in the design and implementation of data-driven systems in supply chain traceability. He holds several patents for systems that digitize farm waste management operations for bioenergy and whey upcycling. He leads Spain's involvement in TC 347's Ad Hoc Group 6 on livestock activities management. Veronica is the chief executive officer and co-founder at Agrolinera. She holds an academic background in business and management, complemented by a master's in systems engineering from the University of Pennsylvania. She has previously worked for the U.S. Environmental Protection Agency in Region 3 and currently leads Agrolinera, focusing on the interaction between agri-food production models, circular economy practices, and rural territorial dynamics at national and European levels. And with that, I'll now hand things over to Juan Gutierrez and Veronica Menendez to begin the presentation. Esteemed speakers, the floor is yours.
Thank you very much, Andres. Hello, everyone, and thank you all for your interest. We believe this topic is both an opportunity and a responsibility for ISO, and particularly for TC 347. It's an opportunity because the wider impacts of agri-food production matter today more than ever before. But it's also a responsibility because the decisions we are making about those impacts will shape the agri-food systems and also our communities. But we are making many of those decisions with limited information. Although we build standards to ensure the interoperability of data, data is only useful for decision-making if it reflects the full context of the decisions being taken. Many of those decisions depend on environmental and social impacts, and these impacts often appear as external effects that go beyond the boundaries of an agri-food production activity. So as a result, they are ignored or misrepresented. This is why we are proposing a new ad hoc group focused on modeling these externalities for decision makers. Today's objective is to explain what we mean by externalities, why they are important, what challenges exist, and what are the goals of this proposed group We are not deciding specific deliverables or methodologies today. Externalities are the impacts of economic production that affect external stakeholders. These are not priced into products and are not borne by the decision maker. They are unintended consequences. They are not unexpected, but they are often disregarded because they fall outside the immediate operational scope. They are part of the non-monetary value of the production. They don't translate into price signals. They can be positive or negative, but in order to make decisions, we need to go beyond simply just acknowledging them or labeling them as good or bad. This creates a structural problem in our agri-food systems because we can capture and optimize what we can measure and agree on, like production data, operational events, yield metrics, or efficiency indicators, but significant parts of the value remain invisible, not because they are important, but because they are not represented in a reliable way to make the decisions we need to make. And a clear example is traditional farming. Traditional farming preserves landscapes because it maintains rural population, and this population reduces the risk such as wildfires in rural communities. These are positive externalities that benefit society as a whole. These effects are indirect and unintended, meaning that no one sets up a dairy farm just to protect the environment, for instance, or to keep the rural population, but these effects are real and happen nonetheless. But agri-food systems change, and as they change, we need to manage them and their impacts they produce. For instance, one major trend is the intensification of smallholder dairy farming in developed countries. Traditional farming is the majority of the sector, both in developing and developed countries alike. So this issue is quite representative. As this happens, practices that were once circular start becoming sources of environmental and social problems. Manure management is a very clear example. Traditional spreading generates different externalities depending on the farm type, the farm size, and the type of territory it is located in. Modeling these effects is important also for new industries such as bioenergy. Bioenergy, biomethane, and biogas can be part of the solution to treat this manure, but they need to prove its net contribution to the community to obtain the social license from authorities and residents. On the other hand, industrial farming has cost advantages in production, but also has a very different externality profile than traditional farming. We have to note also that these externality profiles always depend on the territory. In every case, these effects must be evaluated and managed objectively and neutrally, meaning that we cannot favor one production model over another, but we need to enable an optimal mix from an environmental and social standpoint. The problem is that today, these side effects are invisible to consumers and regulators. Consumers and regulators mostly see just the final products and conventional reporting metrics, but in the product is generally very complicated to see this. And this is where TC347 becomes critical to build our agri-food systems. We need a shared and full understanding of the reality in order to be able to manage it. Digitalization makes data available for decision making, but this is not enough. To make it useful, we also need this data to be relevant and meaningful. And this is why the title of this technical committee, Data-Driven Agri-Food System, has three important implications that require that externalities be included. The first one is agri-food systems have long value chain that intersect with other value chains. Externalities of both types, positive and negative, arise along all these links, and different stakeholders also make decisions in each of these links. If we consider waste and byproduct management, for instance, where we focus our activity, is a very relevant example. Manure is part of biomethane and dairy value chains at the same time. Its management generates climatic, environmental, and social externalities all at once. And it is subject to decisions and regulations from all sorts: environmental, energy department, livestock regulations, and each of these departments, they don't consider the full picture. They just consider part that is relevant to these regulations. Second, in agri-food systems, we are dealing with many systems at once. These systems are complex and they are interconnected. Externalities arise precisely because of these interconnections. And on top of this, systems are dynamic and change. That meaning that what works today may not work tomorrow. So without understanding the full context we are working in, we are making decisions with incomplete information. This means that we must take into account the externalities when setting rules or setting incentives to the stakeholders. Finally, externalities are difficult to measure objectively, but nonetheless, they are real and they are very important. Most agri-food production occurs in traditional rural communities, and in these communities, non-monetary dimensions such as social, cultural, or environmental issues are decisive. Protected destination of origin communities, where productions are local, are a very clear example of this reality, and this is something that we will see later in the illustration. So as we can see, the need to include externalities is obvious. I mean, there are 4 groups of stakeholders who need this externality information in order to make decisions. The first one is regulators and policymakers, both to implement sector regulations and to define import tariffs that ensure fair trade. There's also the impact funds and financial players who need to allocate capital based on broad impact criteria that we need to measure. And also there is the consumers. The consumers, some segments want to make informed consumption choices are aligned with their values regarding the production systems. And finally, there is the agri-food industry itself and other related industries that have to prove this positive contribution to the communities to obtain the social acceptance they need to implement the projects. So we see 2 areas where immediate progress is possible. The first one is waste and byproduct management, which is also an enabler of circular economy, but it's also a source of positive or negative externalities. In fact, there is a growing social debate, particularly around biomethane projects, because they can create problems, or they can also be a very useful agri-food and clean energy infrastructure that creates value to the territory. But for this, we need relevant data to understand and manage exactly this contribution and be able to prove it in a way that is objective and robust. The second area is measuring the advantages and drawbacks of different farming systems in their territories, or what is the same, says their social and environmental contribution to the community. Traceability and data spaces already allow us to capture and convey these signals to the decision makers to incentivize beneficial production models. But what is missing is a credible and sharing standard that can represent these impacts with context. So we need this to keep regulators and consumers and help them drive positive change in this. In both areas, there is a clear need for a standard that brings clarity and consensus. We need consensus about the broad social and environmental implications of these externalities in agri-food production. And for this, we need structure and semantics. If we are able to represent the full social and environmental context of the agri-food production in a way that is shareable and meaningful, we can help decision makers take it into account when they make the decisions. ISO is the right body to take on this responsibility. ISO is global and is also addressing related issues within TC 347. This will give more value to the work that is already being done in other ISO groups. And also, it will fill a stakeholder need for standardization of these external impacts. This work is also aligned with the original scope of the committee. And given the progress of other ad hoc groups, we believe that this is the right moment to launch this initiative. The good news is that we already have a very solid foundation in ISO. ISO 7673 defines indicators, and ISO 19131 and 19157 address data quality. Our goal is not to reinvent methodologies. It is to craft a robust framework to represent the externalities in a usable way to the stakeholders. This framework has to be comprehensive to be relevant, and also data-driven to be transparent. So to be useful, the scope of this work must be clearly defined. This will be an enabling, it will be a non-normative standard. We will not prescribe methodologies, rankings, or valuations. We will just describe what it is, not what is good and what is bad. And this approach is similar to the work that is already done, for instance, in ad hoc group 6 livestock systems. We will define the use cases, identify the events that generate these externalities, model the entities that are related with these events, and keeping consistency with other groups' entity models. In this way, we will create impact indicators that are defined at farm level and also that can be aggregated according to the needs of the stakeholders who will use these indicators. Here is the objective of this group. The key is usefulness. Externality indicators are structured representations of reality, and they must be meaningful and credible. We need this in order to be useful for the system decision makers in a way that can actually be a sound basis for other methodologies that we will not dive into. So the challenge is to make sure that the externality data is collected in a practical, economic, and verifiable way. And this is not straightforward because externality data sources generally are mixed. Some can be automated, some can be documentary, and some part of the data can also be subject to third-party certification. So we will not be prescriptive. We will focus on the data quality and the properties that we require. And for doing this, we will use frameworks that already exist. And this is why this work complements and does not overlap with other ISO group on sustainability. We are addressing and we are integrating part of the reality that is important, but has traditionally been overlooked. And for doing this, we are using existing ISO frameworks that integrate this reality in relevant indicators that are going to be useful for the decision makers. To be precise, we will model 3 types of externalities. First, environmental externalities at the production unit level. These are the externalities created and affecting local communities. And 3 key examples in this category are waste and byproducts, and also impacts on soil and water. Also, we address climatic effects that operate at global scale. And for this, we will be building on all existing methodological work. But we will focus and integrate these externalities at the production unit level. And finally, we will also include socioeconomic contributions across different dimensions, from cultural heritage to local economies, all linked to the territory where the externalities happen. And now, to avoid getting too general, my partner Veronica will illustrate this approach with our own experience. Thank you.
Hello. Thank you, Juan. Thank you, Andres. So we joined ISO TC347 about 1 year ago while working in a project to collect and upcycle the cheese whey from artisanal cheesemakers in Cabrales. So Cabrales is the name of a cheese PDO in Asturias in the north of Spain, which is in the heart of the National Park of Picos de Europa. It is just one of the about 300 cheese PDOs in Europe. In PDOs, community food production has a special status because they use local products and are rooted in territories with very strong identity. There are PDOs in cheese, also olive oil, wine, meat, and many other products. So in a nutshell, Cabrales is an artisanal cheese-making community in a protected national park producing under PDO standards, and it's essential for maintaining population, landscape, and the biodiversity. We found that its population is very isolated and aged. Its economy depends on small dairy farming and seasonal tourism. Cheesemaking is a key part of the territorial identity and economy because it supports the dairy farms. But it also generates cheese whey, which is a highly polluting byproduct, very costly to manage when we are at a small scale. This is a problem, especially here, because we are working in a mountain area with very difficult logistics. So what we did is we digitalized its collection at community level using connected equipment. The purpose is to enable circular uses for this cheese whey while maintaining traditional activity and protecting the environment. So in this pilot, as we start putting all this whey collection system in place, one thing became very clear for us. These small cheesemakers play a much major role than it might seem at first sight. They pay better prices for the local milk, which helps smaller farms viable. Cheesemaking attracts visitors and preserves the local identity. To set incentives and KPIs, we are already capturing metrics at the level of each cheesemaker. But we also have to communicate those individual contributions to our stakeholders and also to theirs. For this, we need shared and widely understood social indicators. We are already capturing many of these metrics at a producer level, but today, these metrics cannot travel across systems or stakeholders in a consistent way. We need a standard way to represent these impacts and contributions so they can serve as a consistent basis for decision and rules. By decision makers, we mean regional authorities who shape policy and sponsors who finance the whey collection infrastructure, for example. And beyond institutions, there is always the consumer at the end of the value chain. So we need to make it possible for these cheese makers to differentiate their product and for consumers to support the production models that are aligned with its values. So this is a need shared with any project aiming to have impact in communities anywhere in the world. The technology is there, it's working, we are using it. The IoT systems we have developed is modular, captures data at source, enables smart traceability and logistics in a fragmented environment. Data supports process efficiency and quality control, enabling way upcycling into other products. It also enables transparency towards consumers and authorities. And that information can travel with the cheese product. But to be completely useful in practice, this picture must integrate the externalities of cheese production and data. In our case, we need to share these metrics as useful indicators with investors, cheesemakers, and authorities. The proposed framework enables all the stakeholders to see the full contribution of producers without monetizing externalities. It empowers consumers and helps regulators establish incentives for beneficial production types using objective criteria. The same approach can help agricultural commodity export communities such as Kenya or Brazil by making data interoperable, verified, and transparent, and by including the externalities of production that are relevant to importers and financiers. We are not replacing certification here, we are enabling a common language that adds value and transparency. For this reason, we propose creating a new ad hoc group within TC347. Its role is to represent and integrate these side effects. It will complement existing work, not compete with it, and help prevent fragmented or ad hoc solutions to this gap. Its work will build on existing frameworks as models already developed in other groups. In this case, for example, you see here, expanding the ad hoc group 6 livestock production entity model. And by making this work consistent, we can also make the rest of the TC347 models more useful. So we encourage you to support this initiative in the upcoming ballot. Those of you familiar with systemic thinking will recognize its transformative potential, not only in the agri-food system, but in the way we live in rural communities and the choices we make as consumers. So thank you very much for your attention. So I now leave the floor to Andres to explain the mechanisms and open the discussion.
Thank you very much, Veronica and Juan. We've discussed creating a new ad hoc group here. So how does this work? Most of the work in TC347 happens online within groups like that ad hoc group that set their own schedule. We do have 2 plenary meetings per year, one of which is virtual. They have happened in October so far. And then the other one of which is in person when we can have it be that way. The work is split, as you could imagine from this talk, into working groups, ad hoc groups, advisory groups that, like I mentioned, set their own schedule and they work on different subsets of what we're working on. So let's imagine that you want to be a part of this. How can you do it? Well, there's 2 primary ways, one of which is definitely preferred, which is working through your national standards body. We have 48 countries that are members of the TC right now. 28 are participating members, 20 are observing members. So if your country's on that list, then you can join your national mirror committee or talk to your national administrator and have them allocate you to this new ad hoc group or to any ad hoc group or advisory group that you want to work in. The other possibility, which is what you do if your country isn't represented or if you're a member of one of our 10 liaison organizations. You see a link at the bottom of this page, that main ISO page link, that will show you which organizations I'm talking about that are our liaison organizations. If you're a member of one of them, it's possible that they set you up as a member. You can participate directly in the work. You can't vote, but that's not very important at the working group level. If you want to know more, please contact us. Either email me or email that information address that you can see there. Reach out to us on LinkedIn. We also have a YouTube channel that you can watch our past webinars in. So let's transition to some questions, shall we? James Lowenberg de Boer, who is the convener of Advisory Group 3 on Responsible Innovation, he made a suggestion. He said, among the groups that this ad hoc group should interact with are national statistical agencies and researchers seeking to incorporate environmental and other non-market factors in total factor productivity, TFP. TFP is used by governments around the world to assess agricultural productivity, but traditional TFP uses only factors that can be easily monetized. The major TFP network is the OECD TFP network group. Juan, Veronica, any thoughts about that, of aligning your work or using your work to contribute to broadening the definitions of total factor productivity?
I think is definitely a very interesting use, when we outline the way we think is most useful to work this, starting with the factors that, without involving monetization, this assigning values to these externalities involves a degree of discretion that might not be commonly shared across the world, and it makes sense because some things have different monetary values in different parts, but it can be a very interesting methodology to build on the outcomes that we want to propose. Imagine that we are building a house. There are many ways to build a house. What we want to focus is on having good bricks, because if we get data that is reliable and it can be properly structured, is meaningful, and can be interoperated, assigning values to this data is going to be much more credible for all the stakeholders. So the point here is to have standards and indicators that are useful. So we focus on building the bricks without price tags, let's call it. But then it's much more easy to make this valuation and assign values in a way that it can be integrated in other methodologies, indicators, observatories, and so on. I think it's a good case.
Thank you. A question for me: how does this work differ from existing ISO work, especially from TC 207 on life cycle analysis, environmental management systems, or sustainability metrics? Why is it justified to start new work?
We believe it's justified, and it's necessary for this reason. I mean, we are addressing a different layer. We focus on the representation of reality, okay, on semantics and interoperability. Most of the previous work does not focus on the interoperability or data quality. It's going to benefit from this approach. Second, we are addressing also external impacts, which generally are left out from these methodologies. I mean, in order to get a full picture of this reality, we have to find a way to digitalize and represent and structure these effects, which are economic effects, even if they are not monetary, in a way that can be credible and interoperable. And it's like the analogy with the bricks and the houses. I think LCA and GHG calculations are fantastic calculations, especially if they are shared by many stakeholders, but they need to have a standard and meaningful, robust, and easily agreed meanings.
Thank you. And James made a follow-up comment about the TFP topic he had brought up earlier, where he says that that group in OECD faces specific challenges with good metrics for non-market factors. There's some data on greenhouse gases and water pollution, but biodiversity and social impacts are more difficult to measure. It's certainly worth taking a look at as we move forward. Then we have a question, I think, from Graham Mullier, where he asks, how practical and how easy do you think it will be to introduce this standardization, given that most of the existing sustainability schemes are commercial food supply chain led? In other words, if they're led by the large players in the industry, what chances do we have of advancing this kind of standard? Are there people interested in it?
We know there are people interested. I mean, in fact, this is one of the challenges we face when we are developing this project in Cabrales, is that generally it's very complicated to understand they ask questions about how many, for instance, how many jobs are you creating with this collection system? Generally, it's very complicated. It's very easy to say, okay, well, I am employing two more people, but that's not the point. The point is how many indirect employment I am creating, and long-term in the system, how much economic activity I am able to support sustainably, meaning that they're going to be still there 5 years from now. And this is a much finer and important question. The way we are addressing this is, okay, we're working in Cabrales, we have several metrics that are straightforward, and we are able to work at individual level to understand where the milk they buy is coming from and so on. So to introduce this standardization is critical if we want to work from the bottom upwards. So how we see if we focus on the production level, on the work that has already been done by other ISO standards, it's not too complicated, especially if we focus on the two cases that we are describing here, which is waste management, which is quite straightforward, and the other case, the measurement of the social contributions in terms of employment generation in rural communities, is a work there is the scaffold to build this.
So Juan, let me pile on to this matter of complexity and system boundaries and so forth. How are system boundaries defined so that the results remain consistent and can be compared across territories?
What we're doing here is we are bounding the indicators, especially at the production unit level, meaning farm level or cheesemaker level in our example. The reason is because we want the indicators to work as the basis to establish incentives, not as incentives, but because we are representing the externalities as observations that are linked to events and practices. If we define the indicators at production level, we are able later to establish the aggregation rules in a way that is more useful for the final user of the metrics. For instance, a region we want to have its own level of aggregation of this production unit, of this farm level, but maybe a biogas plant we want to have a different level of aggregation depending on the territory that is relevant for them.
Just a quick comment, going back to the aspect of semantics and you mentioned, observations as saying that a lot of this is data that can be represented as observations. Well, one of the central ideas in design of the register for the data type definitions for the observations and measurement system is actually to be able to have metadata in each one of the data type definitions describing how that variable can be aggregated or not. Right, like mass and temperature, for example, are very good examples where, yes, mass is something that you can aggregate through, sums. You can treat it as an extensive variable, but temperature isn't. So, like if the yield accumulated in field A and the yield accumulated in field B are like 10 and 20 tons, then you can have a total yield that is, 30 tons, right? But if the temperature in field A is 10 degrees and the temperature in field B is 20 degrees. You can't really have a total temperature of 30 degrees that describes them. So that kind of metadata will be supported to enable, machine actionable aggregation and so forth, like you're saying. So I really like that you're thinking down that road. We've got a couple more comments here. For example, Annika asked regarding Graham's question, how do you balance different stakeholders' interest regarding which is the correct standard way to assess impact?
We are not assessing impact. That's the main point. I mean, we want to be non-normative exactly for this reason. The first step to make this methodology or judgment is to make sure what we mean by the concepts, to focus on the semantics, and then organize these meanings in a way that can be read by the machine. We prefer to focus first on defining basic concepts like what is a cow, what is an impact, what is a specific externality, okay? Not getting into in a way that is a shared meaning across all stakeholders. Then some stakeholders will prefer to have one methodology, some others will prefer to have different calculation methods, but we need to build the bricks first. And this is something that we feel is missing. The key insight we got in working in this project is that there is part of the bricks that have not been developed, and it's an important part of the reality, which are those externalities, those indirect effects. There is plenty of work done in developing methodologies especially for climatic impact and so on. But there's not so much when you go down to the local level. There is, and you see the reality. There is not so much work trying to standardize things that are equally important to generate these signals afterwards. And first, we need to build the bottom layer. Then, if we are able to get this agreement and a standard on what things mean in a way that they can be shared in data spaces, then the next step will be getting agreement among calculations and other things. But that's a next step.
You're working on the language. You're going to let somebody else use that language to set limits on this and that, but you need a language to do that first. And so you're not in the normative business. Whatever normative aspects are in your standard have to do with how to represent these different indicators, not in telling people what an acceptable range is.
Precisely.
And that's a very important distinction.
It needs to be comprehensive.
Mm-hmm. And Annika said thank you, so I think she's satisfied with that answer. Let me go back to something that a follow up on Graham's question earlier. So, who is the intended user of the work that you want to advance here, and how would the standard be implemented or standards be implemented without excessive burden?
Mm-hmm. The users will be the decision makers who are already relying on this data to make decisions. Okay, that's the regulators, the impact funds specifically, and also the industry players who are started working in the scope 3. Okay, because the objective is to make this impact data interoperable through data spaces and improve the decisions they're making. We are not asking decision makers to change the methodologies. We are just giving them a better basis to apply these methodologies. That's why we think the burden is not going to be excessive if we focus on the right part of the job right now. I mean, and the good thing is that we will gain momentum, because if we are able to have these decision makers to use the same methodologies with new data, robust data that is shared and is available and is digitalized, then the rest there will be more implementations of more methodological work being done over this data, because it has one very huge potential, which is you get data that responds to reality, you get data that is robust, and you are able to place this data in digital format. With all the work that is being done now about artificial intelligence, that is considering plenty of data, but part of the data is missing, and it's important. There's so much that it can be done. So going back to the user, there is some data that is very powerful if we are able to plug it into the existing frameworks, but also because this data is traceable, if we are able to include in the value chain and make it the consumer reach this data, we are able to differentiate the products and get the consumer to put the right price signals. So at the end, the consumer is going to be the key user, or at least one of the key users of this data, if we are able to do it, to structure it in a way that reaches the final product.
We have a ballot to create an ad hoc group 12 on smart irrigation, which intends to build on existing work in ISO TC 23 Subcommittee 18 and Subcommittee 19, which are the ISO 22162, I think it is, and the 7673 Part 3 standards, which are fundamentally controlling things at the sort of device level in the case of SC18's work, and at the field level, sort of the production unit, like you mentioned earlier, level in the case of 7673 Part 3. These guys, as they've been thinking about working at a broader scale, like an irrigation district or a landscape, they've realized that there are other phenomena at play, right? There's other decisions being made at different scales. This transcends just aggregation, right? And Graham's asking, have you thought about ways to handle landscape level data and not just farm level? So maybe the whole community, or a valley of interest, maybe like an area that has that controlled designation. So you are being careful in limiting your scope to the production unit. Have you thought about what it would take to make this analysis at a different scale?
It's not incompatible. We can work with production unit and still reach a landscape level. Okay, at the end, a landscape is tied to a territory, and a territory is tied to a group of production units. Okay, so in that sense, if you make the right indicators, you can work with production unit level metrics and adapt those, translate this to a different aggregation level, which I understand it will be landscape level. The reason why we want to focus on production unit is because we can set incentives at the production unit. And if we want to manage a landscape level, okay, you just set up a different aggregation level. It's like you have a group of animals or you have a herd. Okay, at the end, you need to manage the herd, but you need to work with the animals. It's a very interesting question. I understand it's purely methodological, and we can define the structure in a way that it works with landscapes, as long as there is a use case for data, which I'm sure there will be.
That's a good point. Yes, Graham confirmed that what he means by landscape level is taking the sustainability concept broader, because biodiversity rarely stays within a farm boundary.
True,
right?
very true.
And then he says that the incentives idea is important, right? And incentives will likely happen at the production unit level, right? But he says it's worth thinking about landscape level incentives, like for managing water, rainfall flows, water catchment, etc., where monetary incentives may come from insurers.
But it's a very quite interesting question, because the externalities arise from the interaction between economic activities and territories. The landscape is a very close concept to the territory also. So I find this concept, this level landscape, is very close to what we are trying to model.
Stuart Ray asks if there are privacy concerns here. It bears repeating that in many cases, the people more eager to share these indicators are folks who want to level the playing field to show that their production is somehow more friendly, or it takes externalities more into account than some baseline, right? Over to you, Juan. Are there privacy concerns?
At the personal level, no. It's true that at the end, at least in Europe, the owner of the data is the entity that produces the data. But the point here is to use, I think data spaces are going to be a very important instrument here, because the governance layer that introduced into the data is gonna protect the owners of the data. Some of the data we are currently handling have legal connotations. It's true, some of them are not. But at the end, the point here is to make the data interoperable in a way the owner of the data keeps control on them. I mean, data spaces at the end is what is part of the value that they add.
There's a last question from Shafid. You mentioned data spaces. Then why ISO and not a standard within Gaia X?
I think the advantage of ISO is that at the end we want to have a neutral organization and a global organization. That's the two key things. Gaia X is one of the standards, but the point here, I'm not sure if this is necessarily in conflict with what we're trying to do here. Okay, what we're trying to here is to bring meaning to the different concepts we are working in.
Data spaces start from the federated data exchange dimension and don't necessarily dive early into semantics, whereas what you want to do is go in the opposite direction, right? You want to nail down the semantics to enable unambiguous data exchange. So I think that, like what you're saying, these two things are not opposed. Yeah.
We want to keep as close to the reality as possible.
Well, we are at the end of our allocated time. So I want to thank our presenters for their fantastic presentation. I want to thank the attendees for your great questions. And we will see you again very soon in another ISO TC 347 webinar. Have a great rest of your day, and thank you all.